Namaste. My name is Kartikey Gupta and I am Director Programs at Vatsalya. Vatsalya is a non-profit organization working for equitable access towards education, health, well-being for underprivileged children and underprivileged women from economically impoverished backgrounds of society. We have a beautiful self-sustaining campus about 40 kilometers away from the city of Jaipur. And there, a lot of the self-sustaining practices and infrastructure has been developed from the in-house trained beneficiaries. And of course, a lot of global support. Now, today I will be talking about one of the cookers, one of the many solar cookers present at the campus, which is a 10-meter square Scheffler reflector. And we'll be sharing about the data uh, which we have collected over the 4 months for cooking time, a complete cooking log, cooking duration, start and end time versus the meteorological conditions, which include solar irradiance. Now, this presentation has three parts. The first one will be the context setting, what Vatsalya is and what we do. Part two explores this data, and part three explores a little ambitiously a possibility of a scientific correlation for the time for cooking various dishes in field conditions and possible inputs from others and ongoing research which can happen from members of this conference. Okay, sustainable living at campus. These are some of the glimpses at from our campus. This off-grid system was made in-house. No other external company had come. So the youth and students trained inside and under first guided supervision and following standards made this off-grid system, which is responsible for all energy needs, all the electrical energy needs from welding to wheat grinding, everything. Um, and before this, we used to face a lot of power cuts and huge bills, and all that is thing of the past since the last 5, 6 years since we have set up. Um, and then we, of course, have other mechanisms also. We also have biogas, which we use mainly during the monsoons, also at other times. Methane is a greenhouse gas. However, the net effect is very minimal given the amount which we use. And of course, we have our water harvesting system connected to the buildings, which lasts 6 months. The water of 400,000 liters. We practice organic farming using the nitrogen cycle. We have cows, so manure and uh, the compost, biogas, everything works as a cycle. We use the drip irrigation from the rainwater harvesting to harvest that crops. And all these are set up in-house. See, these are some glimpses. This is Sita ji cooking on the Scheffler reflector, which we'll be talking about. Yeah, this is Scheffler 2.0 steam-based cooking system, which was generously given by Wolfgang Scheffler sir and Heike Lee uh, back in 2022. Okay, more glimpses. Wind is like open ventilated areas, and this is 4 feet below the ground, these building constructions using pre-filled water tanks for washing utensils, saving 80,000 liters of water per month. And this is a solar electric oven made of thick insulation, so less energy is required overall. It can make up to 200 pizzas in a day, and this has served us since 5 years now almost. The attitude is kabaad se jugaad. This is a Hindi word meaning um, best out of waste. So a lot of frugal engineering. If engineering is a heavy term, but a lot of frugal things which we can make from a lot of waste. 80% of the school furniture inside is made from the in-house wood and made in in-house carpentry. It's basically the campus serves as a living lab for the children. Now it's focused on STEM. Uh, STEM is a heavy word again, but sustainability, renewable energy education. And these are some of the glimpses. These are all from the last 3 months actually. And this is something interesting. The children had shaped in the shape of farming by learning the areas. So this is half pi r square. It is written over there. And the harvest was, the produce was for children. They ate uh, all of the vegetables they planted. Okay, going to part two. Now, just some parameters of the study. This is the manual logbook entry which has been done for the cooking time, the start and end time, food type and quantity, cooking duration, and the timestamps have been aligned with the weather station data, including irradiance, wind speed, and direction, and others. We did have a pyranometer in the beginning, but it was faulty, so we did not consider the DNI, the direct normal irradiance. The global horizontal irradiance has been considered. Uh, we used this 10 meter square Scheffler reflector for this. One mirror was 20% broken, three mirrors are missing, important to mention. Aluminium foil was the secondary reflector, which was replaced on average after every 20 days. And PGHI was on 30th March. But for a standing reflector, as the summer season comes, the effective aperture actually reduces. This is a photo of a Prince reflector, not relevant here. This is the focal area. Okay. This, I think, is the most important slide of this presentation. So, for all of the dishes made in during these 4 months, when we correlate with minute to minute data for the from the weather station, we get very, very interesting results and how uh, different parameters can have different influence. So this, all of these parameters were measured for all of the food at all of the time which was calculated, and we can, in this file we can filter and check for any food what time, how much time it took. This is of course manual logbook entry from the cooks, but this can be improvised, of course. Um, okay, so immediate observations. This is of course a very apparent and as expected. So this is a scatter plot of different types of foods for the cooking duration and quantity. And for the same quantity of food, it is almost a linear curve when it comes to solar radiance effect for the GHI. So it will the same thing which is taking say 35 minutes at 750 watts is um, taking 60 minutes at almost 60 minutes at 500 watts per meter square. The effect of wind and ambient temperature is not so easy and also not easy to determine because physically also we had barriers to wind and which should be there because convective losses we don't want at the secondary reflector region. So for that we just took a ratio to try to get some idea whether any drastic effect would be there. The 60 degrees has been taken from the studies of solar thermal heating water, the average cooking temperature, and then the categorization was done into high wind, medium, and low wind. And the results we get are interesting, but not really effective for low or medium wind. But for high wind, we do get unpredictability. So this is basically a factor of predictability. And for the high wind, the blue line, we it's a rest predictable behavior due to erratic heat loss. Other cookers data was taken intermittently. This is not sufficient data to graph it out visually at all. But yes, we for other cookers, Prince 15, Parvati, there were other types of cookers also used, and some dry food. This was this slide is just to show that it's very intermittent and depends on the type of cooker, the timing. Okay, now an ambitious approach. Uh, Maybe in field conditions we can get a cooking time formula. And this is possible. Then we are talking about the possibility here. This is not a conclusive thing at all. Far from it, in fact. But considering the basic heat equation and considering all of the factors. I mean, the mass, C and delta T, all of these are self-explanatory for the basics of heat. A is the aperture area of the solar cooker. We're considering Scheffler, but hopefully we can get a universality in the formula for aperture of any solar cooker. And then the factors of temperature, wind speed, humidity, and wind direction. 60 is just to convert it into minutes, but this is not considering secondary reflector efficiency in this case. This sum, this can be uh, made from such data. What I am thinking, some of the values right now can be considered based on the standard text which is available, the temperature, wind speed, humidity, and wind direction factors. Humidity does not really have an effect. I've still taken this into account in this chart, but ambient temperature and wind speed can. Wind direction can be location specific because if there is a northern wind and the north is totally blocked, the effect will be minimal. It depends on the physical space. But of course, this is a very challenging thing. 25 chosen as a thermal neutrality used in the standard test condition. Wind loss is considered at 3% over here. Um, Wind direction again on the site layout. Here, secondary reflector efficiency is not considered. Dish types differ in thermal mass and cooking physics. Human error in logging food timings and quantities. Of course, GHI is from station, not from DNI from plane of incidence for paraboloid. But maybe we can take a small meaningful step towards a heuristic model. Why not? I was just thinking, why not? We can try. So what basically I'm thinking is that this kind of data, this data I think can be gold for research. And you combining advanced weather station with the solar cookers, um, the scientists and practitioners, citizen scientists like anybody here can suggest improvements, corrections, test the models, consider more field trials with different types of cookers, and we will personally carry on this for years because right now it's just a high pressure season. When December to March we took some data, but maybe in the next 5 or 6 years, when we get some interesting data through different seasons, different um precipitation values also sometimes, and many things which affect. In precipitation it is basically zero, but maybe not sometimes, because in the average duration after precipitation the sky clears up. Many factors can affect. So uh, it can be a starting point, and I will invite everybody to make this research at their own solar cookers. Can just correlate with the weather and meteorological condition data, and we can maybe arrive at something conclusive after years of research. So this was from my side. Thank you so much for hearing me out, and I'll be happy to answer any questions.